Hello. Today I'm going to talk about special functions. The first special function that I want to talk about is step functions. Now, step functions are also known as the greatest integer function. And how they're denoted is by saying f of x, and they have like what's called like a double bracket. It looks kind of like this. So it's a bracket on each side, but it's more of a double bracket. And what this means is that in positive numbers, it says f of x will equal, or y will equal, whatever number you put in there, it'll turn it back into an integer. So if I put in a positive terms, if I put in, say, y equals greatest integer of x, and I say y, and I put in y equals 1.5, the greatest integer of that. This is the same thing as saying y will equal 1. If I say 1.4, it brings it back to 1. If I say 1.9, it brings it back to 1. If I say 2.1, then it'll bring it back to 2. Okay, so basically truncates. It cuts off anything after that decimal point. Now, it gets a little different when you get into the negatives. So if you look at this table here, notice that if it's bigger than 3 or smaller than 4, that's 3 point anything, it goes to 3. If it's 2 point anything, it goes to 2. If it's 1 point anything, it goes to 1. If it is 0 point anything, it goes to 0. Now, when we get into the negatives, negative 0.5 can't go to 0 again because 0 is saved for the positive number. So what's right below 0? Negative 1. So 0. So negative 1.2 goes to negative 2. So in the negatives, it turns a little funny. It drops to the lower number. So basically, these greatest integer functions always drop the number value just a little bit. So that might help. When we graph this, it turns into what's called step function. You can see why we call them step functions. When x is 0, y is 0. So there's that point. That's not a problem. When x is, when I greatest integer function say 0.4, it still equals 0. So it stays up and down 0. When I go y equals greatest function of, say, 0.9, it still drops back to 0, so it stays at 0 all the way up to when we get to y equals greatest integer function of 1. Then it finally goes to equals 1. So then it jumps up. So we leave this open circle here and a solid line there, and it jumps to the next value. And then same way, 1.1, 1.2, 1.3, 1.4 all stay 1 until we get over to 2. Then it jumps up to 2. Okay, so the greatest integer function cuts off. It truncates all decimals, so it works only in integers. Okay? Next, a couple more functions you're probably familiar with. The constant function, f of x equals 3, or y equals 3. This is a constant because there's no variable. It doesn't matter what x is. Y will be 3. So if I go up 1, 2, 3, I could pick 3. 1, 3, 2, 3, 3, 3, negative 3, 3. And my line's going to be up at 3, and it's a constant horizontal line. An identity function is exactly this. There is no numbers in front of x. It just y will equal whatever x is. So if x is 1, y is 1. If x is 2, y is 2. If x is 3, y is 3. so on and so forth. And the identity function looks very specific as this diagonal line through here. Next, absolute value. And remember, absolute value makes everything positive. So when x gets below the negatives, it flips it back to positive. So if I'm writing this and I'm writing y equals absolute value of x, when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. When x is 3, y is 3, so on and so forth. But when x is negative 1, it flips back and makes it positive. Negative 1, positive 1. If x is negative 2, the absolute value makes it a positive again. And so you're going to get this V shape. And so your absolute value will look like a V. Piecewise functions, now these are interesting functions. These are like combining two different functions, and just at one point you're going to decide, okay, enough of this equation, I'm going to the next equation. So this is how they write it, f of x equals, and they put these set parentheses. So this top one is going to say when x is smaller than 1, I'm going to follow the equation y equals 2x, but when x is bigger than or equal to 1, then I'll follow the equation y will equal negative x. So it kind of jumps, and it tells you up here what f of x will equal when in each case. So in this case, the dividing line is going to be 1. I'm just going to kind of put that in here as a dotted line, reminding me this is the point where I switch gears and I go to a different formula. So if I'm graphing this, when x is smaller than 1, I'm going to say 2x. So if I wanted to make my table here, if I pick smaller than 1, so we're talking negative 2, negative 1, 0, and we'll even figure out what 1 is, even though it won't necessarily include it. So that will be negative 4, negative 2, 0, and 2. Then, when I get to 1, x, y, I'm going to put in, see, from 1 greater than 2, 3, 4, it'll be negative x, so negative 1, negative 2, negative 3, negative 4. So when I graph this, I'll plot these points, negative 2, negative 4, negative 1, negative 2, 0, 0, and 1, 2. Now remember, x has to be less than, not equal to, less than 1. So we're going to put, but all the way right on up to it. So we're going to put an open circle up at 1. So 1, 2. We're going to put an open circle at that spot. And then I can draw my line. Then, from that point, from 1, I'm going to switch gears. And I'm going to say, OK, switch to y equals negative x. So at 1, when x is 1, y will be negative 1. That's right here. And that is greater than or equal to, so that will make a solid dot, so we know when x is 1 which to include. Negative 2, when it's 2, it's negative 2. When it's 3, it's negative 3. And it can be absolutely any function, any formula. The big idea with piecewise is in this, if x is what? So if x is smaller than what number does it change? And if x is bigger than what number does it change? So that's a piecewise function. So just a quick review, concept summary. We had step functions, which look like steps, greatest integers. So we're cutting off all the decimals. Constant function will always be a horizontal line. Could be up at 3, could be down at 4, could be anywhere. But it's always horizontal. Absolute value functions always look like V's. They're always shaped in a V shape. And piecewise functions, well, there's different points at which they switch and follow different rules for different formulas. So you can make all kinds of different things. See you later. Have a great day.